This research paper evaluates the performance of Whisper, a multilingual weakly supervised speech model, on various Arabic speech recognition tasks. The authors test Whisper's generalization capability on diverse Arabic dialects and accents under n-shot, 0, few, and full fine-tuning conditions. The evaluation covers most publicly available Arabic speech data, including datasets with modern Standard Arabic, MSA, dialects, and accented MSA. The authors investigate Whisper's robustness in unseen dialects and dialect-accented MSA, using XLS-R as a baseline. They find that although Whisper zero-shot outperforms fully fine-tuned XLS-R models on all datasets, its performance deteriorates significantly in the zero-shot setting for 5 unseen dialects. The paper highlights the importance of self-supervised and semi-supervised models in ArXiv, which can learn useful representations from large amounts of unlabeled or weakly labeled data and be fine-tuned on different speech tasks. The authors also emphasize the challenge of Arabic ArXiv due to the language's rich socio-linguistic context and variability. The experimental setup involves sampling audio at 16 kHz and performing pre-processing steps on the text. The authors use transformers for the training and evaluation pipeline and parallelize the model across GPUs to fully utilize the memory. They fine-tune the Whisper and XLS-R models on various datasets, freezing the feature extraction layer and training the other layers. The results show that Whisper's performance varies significantly across different dialects and accents, with notable degradation in unseen dialects. The authors conclude that Whisper's zero-shot performance is not sufficient for Arabic ArXiv and that fine-tuning is necessary to achieve good performance. They also stress the importance of evaluating ArXiv models on diverse datasets to ensure robustness in real-world scenarios. This research paper evaluates the performance of Whisper models on Arabic automatic speech recognition (ArXiv) tasks, focusing on their robustness to various dialects and conditions. The authors conduct zero-shot, few-shot, and full fine-tuning evaluations on Whisper models, comparing their performance to XLS-R models. In the zero-shot setting, Whisper models exhibit good performance on standard benchmark datasets, but their performance deteriorates on dialectal and accented speech. The authors observe that removing diacritics improves zero-shot results, particularly for common voice datasets. For few-shot fine-tuning, the authors train Whisper models on small amounts of labeled data and report improved performance. However, they note that the XLS-R model, which is pre-trained to learn speech representations, does not perform well on few-shot learning. In full fine-tuning, the authors use the entire training set for each dataset and observe that Whisper models outperform XLS-R models across all datasets. However, they note that the XLS-R model with default hyperparameters fails to converge on some datasets, highlighting the need for hyperparameter exploration. The authors also investigate the robustness of Whisper models on MSA accented conditions, finding that fully fine-tuned MSA models perform worse on unseen dialects and accented speech than zero-shot models. They further evaluate the performance of Whisper models on novel dialects, finding that they failed to generalize well on completely novel and unseen conditions. The paper highlights the limitations of Whisper models in adapting to new and unseen dialects and conditions, emphasizing the need for future research to focus on building ArXiv models that are robust to such variations. This research paper presents a comprehensive overview of self-supervised learning in speech recognition, focusing on Arabic dialects. It begins by discussing the importance of robustness in speech recognition systems, highlighting the challenges posed by real-world conditions such as background noise and speaker variability. The authors emphasize the need for large amounts of labeled data, which is often lacking in Arabic dialects due to cultural and linguistic diversity. To address this issue, the paper introduces a novel approach based on self-supervised learning, utilizing large-scale datasets like LibreSpeech, VoxLingua 107, and MGB2, MGB3, and MGB5 for Arabic dialects. These datasets provide a foundation for training robust models that can handle various dialects and environmental conditions. The authors also discuss recent advancements in speech recognition, including the use of Wave 2 VEC 2.0, Hubert, and XLS-R for self-supervised speech representation learning. These models leverage masked prediction of hidden units and contrastive learning to achieve state-of-the-art performance in speech recognition tasks. Moreover, the paper highlights the significance of multilingual strategies for dialectal code switching Arabic ArXiv, demonstrating that a single model can effectively handle multiple dialects. The authors emphasize the importance of considering linguistic and cultural nuances when developing speech recognition systems for Arabic dialects. The paper concludes by discussing future directions, including the need for further research on self-supervised learning methods and the development of more comprehensive datasets that cover a wider range of Arabic dialects. Additionally, the authors suggest exploring new evaluation metrics that better reflect real-world conditions and speaker variability.